So here they gave us u, v, and w function of x and y, okay? And they said that it's an incompressible flow, and we have a Newtonian fluid, okay? Whenever they say you have an incompressible flow, so rho is constant, okay? So first, from this information, incompressible, I have rho constant. And from Newtonian fluid, when they say it's a Newtonian fluid, so I can apply Navier-Stokes equations. So Navier-Stokes equations are applicable. I can use them for linear momentum. Anyway, in this course, we will only deal with Newtonian fluids, because if they are not Newtonian, the equation becomes very, very complex. Okay? And first, we want to verify that the fluid satisfies conservation of mass. Then they ask for the pressure. So as usual, whenever they ask for pressure or for something related to forces, then you should think about linear momentum conservation, like chapter 5. But now, instead of dealing with if you want control volumes at a macro scale, we are working at micro scale. Okay, so first the condition. So since we have incompressible flow, if we go to our formula sheet, so if I go to our formula sheet, okay, I am in which case here? I have steady and incompressible flow. Okay, so I can deal with this relation because rho is constant. Okay, so if you want, even if it's not steady, whenever rho is constant, so this term will cancel. Okay, and rho will be simplified from my relation. So I get del u by del x plus del v by del y plus del w by del z equals 0. This is the condition. So now if I go back to my problem, I want to verify that this equation is satisfied. So let us try to do it. I have u is minus 2xy. So if I do del u by del x, it's minus 2y. Okay? Minus 2y. Now, for del v by del y, v is y squared minus x squared. So if I do del v by del y, it is plus 2y. And finally here, omega is 0. So del w by del z is 0 already. So plus 0. And I can verify that this will give me 0. So continuity equation is satisfied. Okay? So this is my first step. I verified that I have conservation of mass. Second, they asked to find the pressure field, knowing that the pressure at point x0, y0 is equal to P. So whenever I need the pressure field, I will go to my Navier-Stokes equations. So let us see them together. This is the formula sheet. I am working in rectangular components, so I will use the following Navier-Stokes equation in Cartesian coordinates. Okay, so here I will have to use the three relations along x, along y, along z. Okay, because my pressure field can be function of x, y, and z. Now you will see here that a lot of terms will be simplified. First, I have omega of my fluid flow is 0. Okay, since omega is 0, if I try to apply the third relation, nearly the majority of terms will simplify. So del w by del t will be simplified. All of these are 0 since w is 0. Okay, I have here also all of these terms are 0 since w is 0. So I am left with these two terms only. Okay, along z you have the weight. If you take z as, it depends on which is your z direction. So here let's say if you consider the vertical is weight, okay, then you can get from this relation that del p by del z, del p by del z is equal to rho gz. Okay, rho gz, And here, if we are in the case of z in the vertical direction, so it's equal, gz is equal to minus g. So it will give me minus rho g. Okay? So this is the relation along z direction. Now, if I apply my relations in x and y, what do I get? I should go back to my
دكتور
equation.
بس ليش ماينس رو جي؟
لأنه إذا أنا عم بحكي ب if I have this case, for example, if I will go back to the given to see if they gave me any information. If they consider إنه xy is the horizontal plane, so you have xy is your horizontal plane, and z is the vertical. So if you consider that z is the vertical, what is you have that due to the force, which is weight, okay, you have that the component of g in general, you can divide them into gx, gy, gz. But if you take z as vertical, then gz will be equal to minus g, because vector g is downward, okay, is in the vertical direction. So since I have here z is along the vertical, so vector g can be only written as g vector, g as a vector is equal to minus gk, okay, it's minus gk, so it will only have a component along k. This is why I can say that this is equal to gz k. So what is gz? It's minus g, okay. Now, if I consider that I am working in the horizontal plane, in xy plane, because why here I can consider this? Because I have flow only in along u and v. Okay, here you have a flow only in one plane, in a horizontal plane. So what will be z in this case? It will be 0. So if I can consider that I am working. So if you want, since no flow along z, no need to consider del p by del z, because already I'm not varying. I'm always in one plane, okay? Because w is 0. So in my problem, they told me that w is 0. This means that I am moving. So this information will tell me that I am moving in a plane parallel to xy, okay? Parallel to xy. This is why, if you want, I can say, since I am not moving in z, it's true that del p by del z is minus rho g, but I am not moving along z. This is why I will not experience a variation of pressure, since I'm moving only in xy. So the variation of pressure due to z will not affect my motion, because I move in a horizontal plane, okay? So now I still need to find how my pressure is varying function of x and y. Since for me, I will not have the variation because I don't move along w, okay? But if I move along w, then I will experience a pressure variation equal to del b pi del z equal to minus rho g, which is the hydrostatic pressure that we know, okay? Now, second step, I want to apply x and y relations, okay? To be able to apply x and y relations, I should go to my given and see what is u and what is v, okay? So let me go back here. U is minus 2xy, okay? And v is y squared minus x squared. So I will take this relation and try to apply them. So if you want, here, this is what they did. They wrote first the general relation, okay? I will take them for you because they are not including all terms. I want you to see how we simplify terms. So I will take the relations u equal minus 2xy, v equals y squared minus x squared. I will write them here. So in this problem, I have that u is equal to minus 2xy, and v is equal to x squared minus y squared. Okay?
Dr. y squared minus x squared.
Oh, sorry. Y squared minus x squared. Okay. So now I will begin by applying the linear momentum equation along x. Okay. First, u, as you can see in your function, u is only function of x and y, so it's independent of t. So del u by del t will cancel out. It's 0. Now I have u times del u by del x. This term will not be 0 because I will replace u by minus 2xy. And if I do del u by del x, it will give me what? If you derive minus 2xy with respect to x, you will get minus 2y. So I should multiply by minus 2y. Okay? This is u del u by del x. Now, for v, if I replace v by its value, I have plus v is y square minus x square, y square minus x square times, I should multiply this by del u by del y. Okay, what is del u by del y? It's minus 2x, so it's times minus 2x. Okay, now I don't have w in this problem, so this term will cancel out, this one. So I can say that from the first side I will have this expression equals to, from the other side equals to. We said that z is the vertical, and so because z in this problem is along the vertical, then g vector will have only a component along z. This is why rho gx will be 0. Okay, so I will get from this side minus del p by del x minus del p by del x. And now for the other side, what do I have? I have, look, u.
دكتور رو جي اكس هي 0 لانه ما في بس على الزد جي صح؟
صح. يعني هون z is vertical, I am moving in a horizontal plane, so gx is 0, gy is 0, and gz is minus g. Okay, now if I do the second derivative of u with respect to x, I will get what? I will get 0, because look, u is minus 2xy. When you do the first derivative with respect to x, you get minus 2y. If you derive another time with respect to x, it's what? It's 0. So it's plus mu times, so 0 for the first term. Now also, if I derive del u by del y will give me minus 2x. If I derive again with respect to y, it will also give me 0. So it's plus 0. And u is already not function of z. So del u by del z is 0. And the second derivative with respect to z is 0. So plus 0. So you will see that in general, these equations which seems complex will be much simplified in reality. Okay, so now what do I have? If I write my equation here, let me do the development. I will continue the development here. Okay, I will do minus 2xy times minus 2y, so I will get plus 4 times x times y square times x times y square. And for this term, if I do the expansion, I have minus 2xy square minus 2x times y square, and plus, because minus minus, so it's plus 2x cubed plus 2x cubed equals to minus del p by del x minus del p by del x. Okay,
Doctor,
yes,
بس can you repeat ليش the 0 على اليمين تبع
yes, the second derivative.
Yes.
Okay, you have to do the second derivative, you do first the first derivative. U is minus 2xy, so del u by del x, del u by del x is equal to minus 2y. Okay, now to do the second derivative with respect to x, you should derive this expression. Del u by del x is function of y, so it's not function of x. So if you derive this with respect to x to get the second derivative of u with respect to x, what do you get?
0.
0. This is
okay,
why del
doctor.
square u by del x square is 0. The same for the second term. If you do del u by del y, it's minus 2x. It's only function of x. So if you derive now with respect to y to obtain the second derivative, it will be 0 also.
Yes, thank you, doctor.
Okay. So I obtained now my first relation. I obtained del p by del x. Okay. When you obtain del p by del x, you can derive an equation of pressure, but it will be, if you want, plus a certain function of y, because when you integrate with respect to x, we'll consider that y is a constant. So if you want, from this relation, I can get a first expression for p. So p as a function of x and y, I will obtain it from integrating this relation with respect to x. Okay, and keep in mind when I integrate with respect to x, I consider that y is a constant. So here the first term is 4xy squared. If I integrate with respect to x, I get that I have 4y squared, which is like a constant, times what? X squared over 2, because the integral of x is x squared over 2. So if you want,
you can simplify our two terms. زي 4xy squared minus 2x.
Just guys, 1 second. I want to put it on the charger, the computer. Okay. So here I can simplify because it's x squared over 2 times 4. I can put instead of 4 over 2, 2. So it's 2y squared times x squared. This is the first term. Now for the second one, I have also...
دكتور بس هي مش هي صح
Okay.
بس هي 4xy squared minus 2xy squared مش هي 2xy squared فرد مرة
بلا مظبوط ما انتبهنا لهيدي. Yes, true. So here I can simplify it. So فيني فرد مرة حتى إذا بدكم هعملها دايركتلي هون. اوكي هي 4xy square minus 2xy square يعني 2xy square, and if I integrate بيطلع لي y square times x square يعني بلا 2. اوكي بلا 2. شو بيبقى لي؟ بيبقى لي plus 2x cubed. So if I integrate this term, it's plus x4 over 2. Okay, plus x4 over 2. Plus, don't forget to add what?
Function of y.
Add function of y. Plus function of y. Okay. Now, how to determine the function of y? To be able to determine function of y, I should go now to my second relation. So I should find what is del p by del y. Okay. ساعتها del p by del y I obtain from here. I equate it with del p by del y I can get from this expression. Okay. Because from this expression I can say what is del p by del y from this expression. Del p by del y, I derive this relation. When you derive with respect to y, you consider that x is constant. So for the first term, you have 2y x squared. So equals to 2y. Guys بس انتبهوا على شغلة في minus. Okay. لأنه هي minus del p by del x. يعني if you want هون بدي أحط, I should put minus before it. When you integrate, حطوا minus قبلها لأنه it's minus del p by del x. Or if you want, you can take the minus to the other side also. Okay. يعني هون minus del p by del y will give me what? Will give me.
دكتور بس ما بتطلع x squared y squared.
شو هي؟ بلا ايوه شو هي الاكس سكويرد؟
اول شيء اذا هي بتطلع 2xy squared.
بلا عملناها اكس سكويرد واي سكويرد، كتبناها اكس سكويرد واي سكويرد. اوكي وثاني وحده x4 over x to the power 4 over 2. Okay. Now to get when I derive this relation with respect to y, to get an expression of minus del p by del y, what do I have? If I derive with respect to y, the first term will give me 2y times x squared because I treat x as a constant. And The second term x4 over 2 the derivative is 0 لأنه I consider it's a constant. So بيبقى لي plus del fy and you can write it لأنه f is only function of y فيكم ما تكتبوا del بتكتبوا df by dy. Okay? So this is the expression I can get from this one. I can get the following relation. Now I need to be able to obtain fy. I should find what is minus del p by del y, and as you can see, minus del p by del y I can obtain it from here. Okay, so now to get minus del p by del y, I should apply what? I should apply the linear momentum in y direction. Okay, let us do it together. So first, we have that v is y squared minus x squared. So first, v is not function of time, so del v by del t will cancel out. You have for u del v by del x, I will replace u by its value, so it's minus 2xy, okay, and times del v by del x. Del v by del x is minus 2x, okay, so times minus 2x. Now plus v del v by del y, so it's plus, for v I replace by y squared minus x squared, y squared minus x squared times del v by del y. Del v by del y is 2y, so times 2y. Now w is 0, so this term will cancel out this one. Okay. Now from the other side, what do I have? I have it's equals to minus del p by del y, minus del p by del y. Now for gy it is 0 because we said that vector g is along z, so no gx, no gy. You will have gx, gy if you have your coordinates inclined. Yani if you don't have z along the vertical, then g will be decomposed into gx, gy, gz. But here it's motion in a horizontal plane, so z is the vertical. This is why gx and gy are 0. Now for the last term, also here, let me check if I have second derivative or not. So first, for v, to get the second derivative of v with respect to x, I will first compute del v by del x. Del v by del x is equal to minus 2x. Minus 2x. So here, the second derivative will not be 0. Okay? If I do the second derivative of v with respect to x, I will get what? Minus 2. Okay? So del square. So del square v over del x square is equal to minus 2. Okay? So this is, I can replace del square v by del x square by minus 2. And now I should compute del square v by del y square. So now I should do del v first over del y. I will get equal to plus 2y, plus 2y. Okay. And now if I do the second derivative, so it will give me what? So now second derivative of v with respect to y will give me all plus 2, because here 2y, the derivative of 2y with respect to y is plus 2. So you can see that minus 2 plus 2 will cancel out, and v is not function of z. So I can say that here, if I replace, this term will cancel because it's plus 2 and minus 2. So I can deduce that what is del p by del y? So minus del p by del y is equal to the following. Here, if I do expansion, I get minus 4 x squared y, minus 4 x squared.
مش 4x squared y.
بلا 4 لأنه في minus برا وجوا. Yes. So plus 4 minus it's plus. So plus 4x squared y. And I have plus 2y cubed plus 2 y cube and minus x 2y x square. Okay, so minus if you want x square times 2y minus x square times 2y. Okay, so now here also I have terms that can be simplified. Okay, you have that 4x square y and you have minus 2x square y. It will give you, it is equal to 2x square y. Okay, and the second term is plus 2y cube plus 2y cube. Okay, so now if you compare with the other expression, what was your other expression here? You have, this is equal to, by comparison, it's equal to 2y x square plus df by dy. Okay, now look what will happen. You have the term, this one 2x square y is the same. Okay, for both. Yani here what you can, oops, look, you have 2x square y is repeating in both, so it will cancel out. So you deduce that df by dy is what? What is the remaining term? The remaining term is 2y cubed. So you deduce that df over dy is equal to 2y cubed. Okay, and now you can find f of y by integrating, and as expected, f is only function of y. Yani if you obtained in your expression x, you should know that you have a calculation error because f is only a function of y. Okay, so now if you integrate, you get that f of y is equal to y4 over 2, y to the power 4 over 2 plus a constant, Now, to finish my problem, I still only need to find this constant. Okay, to find this constant, I need a boundary condition. So let us go back to our problem. They gave me a boundary condition. Okay, so if I go back to the problem here, so they did the same strategy we did. They started with Navier-Stokes along x, then Navier-Stokes along y. They got the simplified form, okay, and then by doing fy, we got that fy is as expected, it's minus y4 over 2. But here, let me see, we have rho. Yes, look, what we have missed here, we have rho outside of the here. Don't forget to multiply by rho, okay? So it's rho times u del v by del y, etc. This is why we have rho here in the expression, okay? So now, the final step is what? The final step is to get the constant. To get the constant, I need a boundary condition. If I go back to the given, they told me that at point x equals 0, y equals 0, the pressure is equal to PA. Okay, so all I have to do now is to replace for x0, y0, P equals to PA, and I get my constant. So here, reaching this relation here, I say to find C for x equals 0 and y equals 0, I have that P should be equal to atmospheric pressure. And if you replace in your equation x and y by 0, you will get this is equal to C. So your constant C is equal to PA. So now you
دكتور
close
احنا دي
your
اف باي دي واي طلعت معانا 2y كيوب يعني minus 2y كيوب.
لحظة خلي let me make sure.
في minus
نحن كان عندنا ماينس برا I think to the other side.
مع الماينس ده اللي رو على ده
yes هلا anyway تشوف إذا بعدها مكتوبة عنا. لا ما بقتها مكتوبة عنا. Okay. So here if you want, it might be نحن انتبهنا نحط الماينس لدال بي بنكون شي مطرح نقصنا ماينس. اوكي، لانه pay attention انه هون you have minus del p by del x و minus del p by del y. اوكي، so بيكون شي مطرح نسينا نحط ماينس من هيك طلعت هيك. that's it. and don't forget الرو كمان. هيدي الرو ما تنسوها، انه you should multiply u del v by del x plus v del v by del y plus w del v by del z by rho. ففي كمان you should multiply your results اللي طلعنا here by rho. اوكي، so
دكتور اذا قالوا لنا
نعم
neglect the shear forces او shear stresses او شيء، فينا دغري تاني term نحط زيرو؟
yes of course، لانه هيدا due to viscous term. هيدا يعني بالlinear momentum عندكم هيدا الترم represent the pressure forces، هيدا الترم represent the viscous forces، والترم الرو جي represent البادي forces الويت. okay، so here after you use your condition, after you replace by your condition, you get C, and now you can find the expression of your pressure. okay، فجايز
دكتور يعني سي
طلعوا
هون شو طلعت؟
هلا تقلكم ليش الماينس، لانه نحن انا وياكم حطينا ماينس دل بي باي دل واي. اوكي، equal to something plus f، يعني الاف تبعهم هي العكس الاف تبعنا. this is why. but when you replace back in your relation حيرجع يطلع لكم اخر شيء the same result. اوكي، يعني that's the whole idea، انه نحن اشتغلنا على minus del p by del y، هن اشتغلوا على plus del p by del y، مشان هيك طلع لهم الريزلت هن minus 2 rho y cube، بينما نحن طلع لنا plus 2 rho y cube، لانه الاف تبعنا هي عكس تبعهم. but when you replace back, when you take this minus، نحن هيدا الماينس تركنا لها المال، when you take it back to the other side you will get the plus. okay، يعني نحن الفرق الوحيد بيناتنا وبيناتهم انه هن عم بيجيبوا دل بي باي دل واي، نحن عم نجيب ماينس دل بي باي دل واي، مشان هيك الاف تبعهم حتفرق، حتكون ساين اوبوزيت تبعنا، فنحن مش عاملين calculation error. and if you replace at the end you will get the same relation. okay، any other question on this problem?
الجي زاد اخذناها ماينس جي كأنها فاكتور فورم.
yes، ما هي الفector g عنده 3 components. vector g can be written g as a vector is equal لما يكون z vertical it's equal to minus g k. يعني what you can conclude gx is 0, gx is 0, gy is 0, and gz is minus g. okay،
بس هون نحن ما رجعنا اشتغلنا على third equation لان W هي equal ل 0.
مظبوط، لانه ما في موشن. يعني انت تيكون عندك دل بي باي دل زي مش لازم you should move in z direction.
بغض النظر اذا طلع عنا نحن قلنا دل بي باي دل زد هي طلعت معنا ماينس رو جي،
مظبوط،
بغض النظر اذا طلعت معنا فاليو
هيدي بغض النظر، بس انت اذا ما عم تتحرك بزي ما بتستفيد منها لهالايكويشن. انت بتستفيد منها لهالايكويشن بس تتحرك ان زي. if you move along z you will experience the pressure, the hydrostatic pressure effect. اوكي،
دكتور اخر شيء كيف طلعت معهم بي ماينس بي اي؟ شو عملوا؟
كيف شو عملوا؟ ما عملوا شيء، حطوا هون الكونستنت، حطوا محلها محل سي حطوا بي اي. اوكي،
اللي منا
C
ماينس
is equal to PA. رجعوا اخذوا C لتاني مال، او اذا بدك اخذوا حطوا ماشي، يعني حطوا مطرح CPA بيطلع لهم انه P equal to PA، وعندك minus rho over 2، رجعوا كتبوها مثل ما هي، يعني minus rho over 2 times هيدا 2x square y square plus x4 plus y4. ما عملوا شيء، بس حطوا مطرح CPA، يعني بس شقلبوهم، يعني حطوا هيدا الترم هون وهيدا الترم حطوه ورا بس. that's it. okay، any other question on this problem before we start a new one? okay, problem 7. An oil film drains steadily down the side of a vertical wall as shown. After an initial development at the top of the wall, the film becomes independent of Z and of constant thickness, assuming that W is equal to Wx only, and the atmosphere offers no shear resistance to the film. First, solve the Navier-Stokes equation for W function of x. And second, suppose that the film thickness at the wall is measured. Find an expression which relates mu to the slope del W by del x. Okay, so let us start first by looking at what are the assumptions here in this problem. Guys, do you mind if I open a new session? هيك we can تما نقطش البروبلم. Okay, I will open a new session and send you the link.
Okay, doctor.
طيب